We go to the last session before lunch. Last session, hang on. One more session, you can do this. And it's an interesting session because it's about the state of the ocean and our changing climate, the key findings of the 8th Copernicus Ocean State Report. We got a senior advisor in ocean science for policy from the Mercator Ocean International, and her name is Karina VON SCHUCKMANN. Did I say it right? SCHUCKMANN? I've got all these German names today and Dutch names. Karina, you're a scientist. I have to be honest, this is about communication. What makes you so happy working with this kind of stuff?
Yes, thank you very much for this question. So the most exciting part is that we are able to be a facilitator between the knowledge we can build up from the science community, and I will show you, we will have a large science community in the back, multidisciplinary community, and to work together then also on the one hand on the peer review part, a scientific process, going with experts for communication, for knowledge transfer, for packaging knowledge in a way that we can transmit this to a larger audience. So it's a very exciting part to work on the one hand with the multidisciplinarity, to connect the dots, and also to explore how we can better make that transition in order to improve our knowledge transfer.
I see the sparkle in your eyes. You need the stage. I will give you the stage. Please hold your mic close to
Okay, thank you.
And there's the remote control.
Thank you very much. So I'm happy that I have the opportunity to present you the work which has been done by many, many experts from Europe, experts from all over the world, of this work on the Copernicus Ocean State Report, which is a part of the Copernicus Marine Service, which we drive at Mercator Ocean International. So what we are doing, and I had the opportunity to introduce this with this question at the beginning, is that we use the wide range of data from satellites, data from direct measurements in the ocean, and data from modeling, as we have just seen from Simon before, which are part of the Copernicus service, but also from other data. So we complement together in order to get the most comprehensive picture on the different aspects of the ocean. And then we combine this with the knowledge, with the expertise, with the analysis, with the new exploration of those data, in order to then drive the transfer of knowledge on different tools. And this is one tool I'll explain here, is reporting. So the Copernicus Ocean State Report is an activity which had been launched in 2015 with the first publication in 2016. And we have now done a long journey going up now to the 9th issue, which will be published in September this year. And we will have an anniversary of 10 years in September next year. So what's happening here? So we do this annually as part of the Copernicus Marine Service, implemented by Mercator Ocean International. We provide what we are doing. We provide information on the state, the variability and the change of the ocean, the many aspects, from the blue one with respect to the physics and, for example, climate aspects, the green from the biogeochemistry, biodiversity and ecosystems, and the so-called white ocean, where we tackle all the aspects in the cryosphere, so the frozen parts in the Earth with respect to the ocean. And so we provide also key inputs that support the major policy at EU level, but also at international level. And we have collaborations around, so it's fluctuating from less and more. 150 experts, multidisciplinary experts. For the last report was 25 institutions. This number also changes from Europe and also around the world. So what is the content? So we organize this in a way, so this is a scientific work we are doing. We have one chapter where we really have a closer look on the synopsis, on the changes, report every year what is happening, and also making linkage to socioeconomic implications. We look here at new pathways, how we can monitor the ocean, where we can regular information to get new methodologies and new understanding on the functioning of the ocean. And then we have a chapter where we look at the changes and monitoring and the data we use and the knowledge in order to drive different aspects and link this to socioeconomic implications. And we have one when recent changes are happening in the ocean, such as the extreme conditions in the Atlantic in 23 or 24. We tackle those type of events we have seen 1 year later with a closer look what is happening for these specific events. So I give you some insights. So what we are then doing is we build a report on a very scientific technical level, and then we work together with many experts to open it. And so this is an example. I will provide you many aspects where we provide a summary of the Ocean State Report, and where we also combine the knowledge we have from the report itself together with other information, such as from IPCC, IPBS, and other aspects, in order to make a comprehensive picture on the topics we have tackled each year. So we look at this for different scales. We look at the global ocean, but we have, of course, also a focus with respect to the areas as defined in the Copernicus service. And again, we look at the different aspects and also its implications. So this is just a glance from the last report, just give you an insight on major themes which we have tackled. And this was a report which had been published in September last year. So we had unprecedented heat waves, where we could see that about 22% of the global ocean surface experienced at least one marine heat wave event in 23. We looked also specifically a bit more regional on these specific aspects and show how they grew longer and where they become more frequent and where they have over larger and longer over the past few decades. And also it shows how it suffers from the grew when they grew, when we look at the longer times here, where these events grew from about 20% coverage up to 90% in this for the recent year. Then we look at rising ocean heat content. So we had heard about this important functioning from the talk of Sabrina this morning. We looked at some unexpected plumes, such as we've done, for example, in the last chapter, where we could see that there was a rise in annual primary productivity of 35%. We look in the cryosphere, as I said, with respect to sea ice changes, deep marine heat waves. So heat waves are not only emerging at the surface, we also have signatures in the deeper layers of the ocean. And that's something really to explore because it can have large implications for marine ecosystems. Record-breaking wave events which threaten infrastructures. And also, we look also on some key innovation aspects to explore how the state of the ocean variabilities are in favor to think about new sustainable solutions for economy. I give you some insights on the general state of the ocean we could tackle. This is, for example, for sea level rise. We could see, we give the information on the general sea level rise over the time on the global ocean of 3.4 millimeters per year, the Northeast Atlantic and adjacent sea. So this is from the 1993 onwards up to 24. And then for the different smaller areas where you can also tackle the difference and compare this, how fast the sea level is rising in these different basins as compared to the global mean. And we have done this also at a very regional scale, where we show here those areas which are rising faster as compared to the global mean sea level rise, to get a comparison in order to see which areas are affected from a larger threat. Then we do the similar also for the rise in surface temperature of the ocean. So we again provide the average number for providing an overview on the changes we could see. So these are changes starting in 82. This is according to the measurements available from satellite data. And we also provide again the map to identify which are the regions which are rising faster on terms of surface warming as compared to the global mean. Then we tackle also the aspect on ocean warming. The explanation had been provided. Ocean warming provides us the information on the state and the future perspective of global planetary warming. And we provide every year a clear indication. We combine here data from Copernicus Marine with international data to see also how those different products compare and how they agree. And we get a consistent picture of the warming of the ocean over the past decades, since the 1960s, to show that the ocean is warming. And we know when the ocean is warming, we know that the Earth is out of energy balance. And this has implications at a wide scale. These are implications on land, like coastal flooding and coastal erosion. These are implications in the open ocean, such as sea level rise, but also with respect to stratification, changes in salinity, also change in the capacity to take up CO2 in the ocean, which reuses with a warmer ocean, and also aspects in the cryosphere and in the atmosphere. So yes, I maybe skipped this one because it had been already explained. It's just to explain you again that this is a key indicator for warming. So the ocean is a sentinel for planetary warming. The ocean guides us on how much heat is available to warm the land, to warm the atmosphere, and also take the warming of the ocean. And as we know, that is out of energy balance. This is the aspect what we do for the cryosphere, again, the frozen parts of the Earth. So it's the cryosphere with respect to the changes in the Northern Hemisphere for the Arctic, for sea ice extent, and the Southern Hemisphere, and also in the European seas, in the Baltic Sea, where sea ice has also been reduced. And we could see that there was only a total coverage of 15% in the Baltic Sea. And at the same time, it was fully covered by sea ice at seasonal scale. And we could see the changes in the Arctic, which had been unprecedented, and in the Antarctic, where we see changes since about 2015 with a rapid drop of sea ice extent in this area. Ocean acidification. We know that because we have the support of the ocean to mitigate climate change, taking up CO2, but we pay the price of ocean acidification. Here shown with an indicator on ocean pH. And we could see also here which are the areas where the ocean pH decreases more as compared to the global mean average, where you could have also had the guidance with respect to the implication for marine ecosystems. We also look for specific here on the extreme events as seen here for marine heat waves, with some closer look on some. So this is the marine heat waves you could see 23 and 22. Again, this was the publication in September 25. And we will update this for the upcoming report in September this year. And so we see, we study the different events. We look also not only at marine heat wave events, we look also at wave extremes, we look also at phytoplankton plumes, and we also discuss the different impacts of the marine heat waves together with all the experts from the different disciplines. So we could see that there are, again, the numbers which we could extract, and you will have the slides in order to take these numbers, or also the summary where we provide all this information. And something, for example, we also make an evidence is what I just said before, is that the marine heat waves is not only occurring at the surface of the ocean, but there's a signature also in the deeper layers. And there was, for example, a specific study which could show that the marine heat wave was extending not only, let's say, in the very upper layers, it was really going very deep below this intermediate layer, going deep 700 meters, affecting not only the physics, affecting the biogeochemistry and the ecosystems. And so just to show you that we also do in this summary, we provide explanation how this works, what are the known drivers today for marine heat waves. And so we tackle this and detangle this information to inform, and then to not only be able to report, okay, we have seen a huge marine heat wave, but to understand also what are the drivers, because often if you're approached by media and there's an event happening, the question is, why is this happening now? But we need time, we need to look at the data, so we can't provide this information, but at least it provides you a bit narrow view. What are the known drivers we know today in general, so that we can start from an early moment to provide information, and then when new studies coming out, to become more precise in order to provide information what is really happening and why. This is just an example where we had a deeper look at some extreme events in the Copernicus marine areas. The focus, the regional focus, regionalization is very essential today because we need to understand the impact that regions say to take adaptation measures, to take other actions in order to react and deliver with these changes in the ocean, such as here for the phytoplankton trend in the northeast European shelf, or the record heat wave in the region which is around here in the Atlantic. Then we have the Barents Sea in the very north, with also a deep marine heat wave extending up to the bottom, and also changes of heat waves in the Baltic Sea, which had suffered because the focus was often on the areas like the Mediterranean Sea. But all these northern regions are suffering at the same time marine heat waves with comparable also economic impacts, but also, of course, of the marine ecosystems. And wave extremes. So it's another example, wave extremes, such as we look at what happened in a storm, Melilla, and how our forecasting systems had been able to predict and to prevent from large loss and damages, and also aspect of extreme waves which have been tackled from this, and how we can improve our forecasts to predict the flooding and to predict also accurate coastal erosion with respect to those extreme events. Okay, this is for the phytoplankton plume. I think I'm running a bit out of time. And this is a topic which had been already tackled. So also we receive questions. If there are new publications, if you've seen, there had been many publications coming regularly out with a question on whether the IMOC is slowing down or whether there are already indications. And so we receive often information. And so this is, for example, a specific focus we have provided. We had a study in there looking at the meridional overcirculation, but we took also opportunity to provide insights combined with the recommendation from the assessment of the IPCC to reply to this question. And this is still there, scientific controversy. And the reason is often we get approached with this question, please tell me what is happening. But we are able to provide you information at the limits where we have also capacities to observe the ocean. Yes, so. And this is just the final example, so I come to an end. These are the examples how we also look at the conditions of the ocean with respect to the ocean and society, with respect to new innovations. This is an example which had been provided in the Ocean State Report 8 on the conditions to build renewable energy installations from heat power, seawater heat power. And so they have really looked specifically into one area because there are already first tests ongoing to build this type of heat power, which is a very good solution in order for heating, and they could show which are the best conditions to install this type of instruments. And so they worked closely together with the industry in order to extract information from these studies to build to new pilots and to develop this a new branch of industry in support of a sustainable blue economy. And another one with respect to wave events and respect to coastal infrastructures, what is needed, what are the skills today on how we can predict and forecast those specific events to ensure warning, to ensure first preparations for these types of events and for different exposed sectors like harbor systems. So I would like to invite you, so the summary is downloadable for all the years. We will have a publication of the next one this September. And we will also embrace in this new publication an activity which is on starfish. I think you have heard about it, and this will be launched tomorrow. And we have connecting 3 pillars of sustainable development. We introduce new methods, innovations, and we provide the reporting on the recent changes in the ocean, and we will celebrate next year. Thank you very much.
I just realized that you had such an important job, especially because the IPCC is wonderful, huh? But it's once every 8 years with a scientific review, but climate is changing so quickly, so we have to be faster in finding conclusions about the AMOC, what's it going to do? It's about storytelling. How do we reach the people more quickly so they can take action even more quickly and not wait for the next big report. Okay, well, then we start discussions about it, then all the politics change, and then it's 2050, we're too late. So every year a new report can help us, so thank you for that. So that was what I wanted to say. We have questions, just a brief time for questions.
Yes, Helga, just to tell you, there is also an annual climate change report from Copernicus.
En anglais?
Yes. Yes. Oh, sorry, I was... Vous voulez que je parle français? Ah bon, alors je disais qu'il y avait aussi...
Anglais.
Okay, sorry. I'm not sure the language I'm talking. So, in fact, there is another climate change report, an annual report from the Copernicus Climate Change Service. So you get 2 reports from Copernicus, this one and another one. So you don't need to wait for 8 years. Also for other aspects. My comment is that these slides are outstanding. And probably you could consider producing a set of slides like this for communication use in addition to the report, because the report is a collection of very interesting, comprehensive articles, the global oceans that you wrote in issue 8, etc. Of course, you will have the indicator of starfish. But for communication purpose, I found personally these slides excellent because you show what happened in different parts of the world, you have key figures, and you probably can take material from that, talk to her or others, and for your stuff. So maybe it's a suggestion.
It's not a suggestion, it's just the need of science to communicate with this kind of visuals. We're just visualize everything on social media. Text, we don't read text. We just see an image, and if it's interesting enough, then we go to the text.
Yes, thank you very much. So I just wanted to highlight that all those images had been cut from our summary, so which is available. But I really appreciate we will additionally provide different formats, and because that's also why we are here, to dialogue how we can improve, how we can better facilitate the exchange. So that's a good point to add more and to cut it down into more accessible material. Mm-hmm.
Yeah, thank you for the addition of Copernicus. I'm very grateful to them. That's the same what... do I say it wrong? That's the same what Climate Central does, giving the images, and the images will help us to make the storytelling around it. That's true. Paul, any more questions?
Yeah, hi there. I'm Paul Gross, who's been communicating with you and Sabrina in the last couple of weeks. Quick question. This is the first time I've heard that the highest waves are getting higher. I'd not heard that before. Is this because the sea level is higher, so the height of the wave is higher, or are the waves themselves getting bigger? And then what is the cause? Is it wind? Is it ocean chemistry? What is causing the waves to be higher?
Thank you very much for this question. So for the specific study taken, so the local effect, so it can be a mixture of local effects. So if you come to the coast, there's the bathymetry and all this plays a role. On the long-term aspects, I think these are also multiple aspects. You have, as you say, changes in the sea level. You have changes also in the forcing in the wind, right? You have, for example, in the last IPCC, it had been stated that we have an increase in the intensity and the frequency of extreme waves. And those, in turn, are one of the major drivers for also having an impact on what is happening in the ocean. So for this specific study, the drivers directly, one has to consider also local effects. Of course, you get my scientific reply, to be very careful. But yes, there are aspects of climate change which drive those.
Okay, Karina, thank you very much.